permutations with repetition? How many permutations are there of the letters A, and A? There is just one. Doesn't matter how I flip them around, which A I put first, it's still going to be the permutation AAA. So obviously that's the same condition when you had the 3 Canadian flags. There's only one permutation. Here's the theory behind it. It says given a set of n objects in which there are A of one kind, B of a second kind, and C of a third kind, then the number of distinguishable permutations is n factorial divided by A factorial times B factorial times C factorial. So how we deal with repetition? Well, I'm going to start this way with the blanks just the way we would normally have done it before. And we would have said, well, there's 3 objects, so there's 3 choices for the first spot, and there's 2 choices for the second spot, and 1 choice for the third spot. And what's the way I can write 3 times 2 times 1 if I'm feeling really lazy? I can smush that into a 3 factorial. The only thing that's different now is because of the repetition, we divide by the number of objects that repeat. We divide by the number of objects that repeat. How many times does a 3 repeat? How many times does it, I told you the answer 3. How many times does an A repeat? So I have a 3 factorial on the bottom to represent the repeating A's. What's a 3 factorial divided by 3 factorial? 1. That's why it ends up being 1. So if we go back and look at the flags, if we look at our first pile, we would have had our 3 blanks. How many choices for the first? And then 1, which is 3 factorial, and 3 factorial is equal to 6. That's why you should have 6 different combinations. When we go to this one, we still would have had a 3, 2, 1 on the top because we had 3 objects, which still gave us a 3 factorial, but we would need to divide. How many times did our Canadian flag repeat? Twice, so we would divide by a 2 factorial. So a 3 factorial divided by a 2 factorial. 3 factorial equals 6. 2 factorial equals. This should not take you this long. This is not a trick question. 2, what's 6 divided by 2? 3, and that's why you had 3 combinations for the second pile. The third pile, we would have started the exact same way with a 3 factorial on the top because we had 3, 2, 1 possibilities. You can't see that. But how many times in our third pile did our Canadian flag repeat? 3 times. And there's our 3 factorial divided by 3 factorial. You can pile those up, put them by the side. That's the only thing that's going to be different today is when we did permutations the last 2 classes is we didn't give you repeating objects because you didn't know how to deal with them. What we're going to do today is throw in things that repeat. So we're still going to do our cases and our different restrictions and all that other stuff. Just now we're going to have a repeat. Example number 1, how many 5-digit numbers can be made from 46,164? How many blanks would you like to draw? 5 sounds good because it says 5-digit number. How many numbers do we have to choose from? In the first step, don't think about the repetition, just fill in the numbers like we would have before. So how many numbers are in 46,164? How many numbers do we have to choose from? Don't think about the repetition, just count the numbers that are there. So there are 5 to choose from, and then. So I can just write this as 5 factorial, which we already know is 120 because we memorized that last class. And the only thing that's different is now we look at what repeats. How many 4s do we have? So I have a 2 factorial on the bottom, and that comes from 2 4s. How many 6s do we have? 2, so I get another 2 factorial, and that's for the 2 6s. How many 1s do we have? So in theory, I could put a 1 factorial for the 1, but why do I not need to put that? Because it's 1, so we don't really count if it's 1. So all I need to take into account is my 2 6s, my 2 4s. So on the top, I've still got my 120. On the bottom, I've got a 2 factorial times a 2 factorial, which would be 120 divided by 4? 30. The only thing that's different from what we did last day is this repetition in the bottom, and we just divide by the number of things that repeat. How many permutations are there in the letters of the word Mississippi? What's the first thing that we need to do? Count the number of letters in the word Mississippi. Offer of 11 sounds confirmed. So I could draw it 11 spaces, but what numbers am I going to put in those spaces? 11, then 10, then 9. So instead of that, I'm just going to put the 11 factorial rather than writing it all out. If your brain still likes the spaces, feel free to write them. Now we need to account for all the repetition. So what repeats and how often? There's 4 I's. And I don't usually show the work, but just when you look back, I'll just make a note that that's why we put the 4 factorial is for the I's. 4 S's, so another 4 factorial. And I hear 2 P's. What about the M? Yeah, so I could put a 1 factorial as we could, but there's no point because it's 1. This would be a calc question, so throw all this into your calc. If you've got the old operating system, just remember you need to bracket. For a 2 factorial, don't type in 2 factorial. What can you type instead? Just 2. Don't waste the time getting the extra factorial, because we know they're the exact same thing. Did I hear that correctly? Just looking for confirmation, 34,650. Looks like we have some confirmation. Questions so far? I was saying to the people who came in late, this is the last time I have to look at your little sleepy faces. Okay, let's do some of the restriction questions. So 3 is one of the digit problems using only the digits 2, 2, 2, 3, 3, 4, 5. How many 7-digit numbers can be formed? How many of these are greater than 3,400,000? Blanks, no blanks, completely up to you, just depends how you want to look at the question. If there's 7 digits, we would write 7 blanks. What are the numbers we would put in the 7 blanks? 7, 6, 5. So I'm just going to start with a 7 factorial. And now we just take care of the repeats. What repeats and how often? Two repeats 3 times. And a 3 repeats twice. Looking for confirmation on 420. Leah's kind of nodding her head, maybe nodding her head. Questions so far? B, highlight or circle or underline the word greater. So we've done questions like this before. Typically, this will introduce cases into our question. So because it's cases, I'm going to do blanks just so we can see visually what we're dealing with. So 7 blanks for case number 1. And just like before, I just go through the numbers one by one. So can we start with a 2? No. Could we start with a 3? Okay, so the first might be a 3. If we start with a 3, is there any other conditions on any of the other spaces? Can we have every possible number after it? Okay, what can we have and what can we not have? Can't have a 3. Can't have a 2. Has to be a 4 or 5. Okay, and I'll fill in the blanks in a second. Let's go on to case number 2. Okay, so we discussed starting with a 2. We just did starting with a 3. Can we start with a 4? Any restriction on the second digit? No. Can we start with a 5? Can we combine that with this case? Yes, so your choice, you can do a separate case for starting with a 5, or you can combine the 4. Why can I combine the 4 and 5, and I can't combine that with the 3? This has a double restriction, has a restriction on 2 of the letters, this one does not. Okay, let's fill in. How many 3s do I have to choose from? 2 of them. How many 4s or 5s do I have to choose from? 1 4, 1 5, so there's 2 of them. Doesn't matter what comes next. I've got 5 blanks, so what am I probably going to write next? 5 factorial. How many 4s or 5s do I have? 2. Doesn't matter what comes next. How many blanks do I have left? So what am I probably going to write there? 6 factorial. So I'm just going to simplify each of these, and then we'll talk about the repetition. So this gives me 2 times 2, which is 4 times a 5 factorial. The bottom might have 2 times a 6 factorial. Now I just want to pause here before we talk about the repetition. Is this 20 factorial? Why not? 4 times 5, 20, easy peasy. Why is this not 20 factorial? Because this is 5 times 4 times 3 times 2 times 1 extra 4. If I made this 20 factorial, what is 20 factorial equal to? 20 times 19 times 8. So those are clearly not the same thing. So you might want to just make a note is you can't multiply a whole number by a factorial. You can't multiply a whole number by a factorial. You can multiply whole number times whole number, which is what I did with the 2 times 2, but you can't multiply by a factorial. Okay, now let's deal with the repetition. What repeats and how often? It's the same as above because we haven't changed anything. We're going to have a 3 factorial, and a 2 factorial, and a here, and a 3, and a 2. A 2, but I wrote a 3. You guys have the calculators, not me. I don't have mine out. For T or 14? Confirm? Okay, second case. Offer of 120. What do I do with the 2 cases? Add that or multiply it? How do we know to add? It's or. So remember those differences between or and and? It's case 1 or case 2, so the total number of permutations, 160. Getting this? Kind of getting this, not getting this. Can't read you guys this morning yet. Okay. Number 4. Same idea, but this time letters instead of digits. The letters in the word barrier are arranged. How many different permutations are there starting with? First is the letter R. How many blanks would you like to draw? I heard 7. What's the restriction in part A? Has to start with an R. So that's showing your work. It's telling me why you're putting the number that you're putting there. How many R's do we have to choose from? 3. And I'll worry about the repetition at the end. I'm just going to fill in the blanks. Does it matter what comes second? So 6 blanks means I'm going to write 6 factorial. Can I combine that into 18 factorial? No, can't multiply a whole number by factorial. Now at the very end, I just take care of the repetition. How many times does our R repeat? So, as we get closer to our exam, which is still 6 months away, I'm going to talk a lot about exam panic. And exam panic is when you're in that exam mode, you're stressed, it's like 2 hours in, you're cranky, it's tiring, and you start doing crazy things. I have seen this on an exam. Can you do that? No. Number 1, can you have just an exclamation point with nothing attached to it? No, so that's kind of an indication. Do you think you can just cancel exclamation points? No. So no canceling at this point. Very rarely would we cancel. We would just throw this into our calc. If you wanted to cancel the 3 and the 3 factorial, what would be left on the bottom? So if you think of breaking down that 3 factorial on the bottom, we could break it into 3 times 2 factorial. Then you could cancel those 3's. But this would be a calculator question, so just throw it in your calc. Don't start doing crazy canceling. So no to that over there. Offer 360. Confirm. B, all 3 R's. What's the difference between part A and part B? All 3, so as opposed to just 1, the first 3 spots have to be R's. How many choices for the first R? And then? So what can I just write in the first blank? If you want to write out 3, 2, 1, go for it. Nothing wrong with that. How many blanks are left? So I'm going to have a 4 factorial. This is not 12 factorial. It is not 7 factorial. It is just a 3 times a 4 factorial. So no combining here, even though they're both factorials. Now we deal with the repetition. What repeats and how often? R still repeats 3 times. Can I cancel here? Yes. Why could I cancel here? And before I'm like, no touchy, do not cancel. They're both factorial. So as long as I'm canceling a factorial with a factorial, we are okay. 24, you already know that, so do not punch that into your calculator. You need to know up to 5 without. Do you see why we canceled in this one and we did not in the last one? Turn and talk to your friend. Tell them why we canceled here, but we did not cancel before. Letter C has to start with a vowel. Still 7 blanks. I need to show some work, so I'm just going to put a V, and that the marker is going to understand you mean vowel from the question. It doesn't mean the letter V. It's going to mean vowel. How many vowels do I have? Does it matter what comes next? How many blanks are left? We still divide by the repetition. There's still an R that repeats 3 times. Please do not put this into your calculator because it's the exact same as what other question? Same as part A, exactly the same numbers. Questions so far? Write down a word, and by that we mean a real word in English, where the number of possible permutations is equal to 5 factorial divided by 2 factorial. Then explain your answer. I'm going to give you a couple minutes, and I want to hear everybody's word. Give you a couple minutes. And there's a word, I have taught this, I don't know, 12 times. There's a word that every single time somebody in the class picks. So I want to see if you guys are going to pick it. And I think it's probably going to be even more popular now because of some kind of current event. That's all I'm going to tell you. So I'll give you about 2 minutes. Share your word with your friend. Make sure it's got that permutation. Then we'll all share a word and see. List 4. Just read to read number 6, little sentence in a book. Don't overthink it. Just read it. Understand, so read and pick out the key words, highlight or circle them. What are the key words you would like to highlight or circle? Still one really important word. Identical is really important in this case. Why is that important? Because if they're exactly the same, that is repetition. People are never repetition. Even if you have identical twins, we still say that they are different people. Which, by the way, even if twins are identical, they have 2 features that are completely different. Anyone know what are the 2 features that are different on identical twins? Fingerprints are different. How are fingerprints formed? I didn't actually know this till last year, so I find it fascinating. It's touching the womb is how fingerprints are formed. So even if you're an identical twin, you're going to touch differently, right? So fingerprints are different. What is the second thing that's completely different? Belly buttons. How is your belly button formed? When the cord falls off, right? So it's going to fall off in a different way. So anyway, people, never repetition. So even if there's 3 kids named Joe, doesn't matter. That's not repetition. Where you're going to get repetition is when you physically see it. So words like barrier, when you can see repeating. Words like hello. Where you're going to miss it is questions like this. So just you want to make a note, watch for identical colored objects. Your brain typically isn't going to pick up on it because you're not actually picturing the cars. You're just picturing cars in your head. It's the same thing with the flags. That's why we had repetition, because we had 2 Canadian flags that were identical. That's an identical colored object. Okay? Again, your brain tends to see it when we're dealing with words like Mississippi because you can see the repetition. This one you tend to miss it. We could draw blanks, but I'm really lazy, so I would just count up the number of cars, which would be how many? So a 9 factorial on the top. Then we take care of the repeats just like before. How many things repeat? Red, how many times? Followed by? Followed by? Offer of 1260. Even though it's all messed